So we are having the clamping unit. As we already mentioned, we are having different types of clamping units in different types of machines. In sophisticated modern injection molding machines, we are having different types of clamping units. And most commonly used is two types of clamping. One is the toggle clamping, and the one is the hydraulic clamping. So what is the function of this clamping unit? Is, of course, it is to open and close the mold. So the clamping unit will help in opening and closing of the mold. It is not simply opening and closing, it needs to provide the clamping force at the time of injection. So that is very important. It helps in opening and closing. Opening and closing, of course, it is required, but more importantly, the necessary clamping force to keep the mold in the closed condition is provided by the clamping unit. And as I mentioned, we are having two types. Toggle clamping system, as we have already mentioned in this picture. You can see at the figure, I will explain. So here actually we can see the mold. So this is very small as far as the other things are concerned, because we are more focusing on this. But for understanding, we can say there is a stationary plate and a moving plate, and as we already mentioned, the mold is kept at the center. And of course, we require this plate to be opened and closed. So this is now in the closed condition. The mold is in the closed condition. So for this closed mold will have the connection using several crossed links. So these crossed links will help in closing the mold, and will have the toggle clamping system in the collapsed condition and the opened condition here. Now the mold is open. So these crossed links are now collapsed. So this will be stretched in this fashion. So simply we can say this is going to be a mechanical locking system that is used. And this system is, of course, actuated by the help of a clamping cylinder piston that is being shown here. We are having a clamping cylinder piston used, and the actuation, that means the links are being stretched by the help of this hydraulic system that is being used. But majority of the force that is required for keeping the mold in the closed condition is being given by the links, that is mechanical links, or simply we can say we are having front link, rear links, etc. These links will provide the necessary amount of pressure that is required to keep the mold in the closed condition. Why we require that pressure? Because from this side we are having very high injection pressure of plastic material that is entering into the mold. So the mold should not get split apart, and we need to keep it in the closed condition, and that force is exerted by using these stretch links. And when we come to the hydraulic clamping system, we will not have this mechanical arrangement. The whole pressure is exerted with the help of pressurized oil. So the oil is being pumped using a pump and a motor. It will be pumped, and the mold is being placed in between the stationary and moving plate, and the whole pressure required is being given by the oil pumped by the hydraulic system. So we are having different arrangements for that. We'll have detailed discussion later, and we'll have a discussion on what is going to be the type of system used in injection molding. So normally we will have, in majority of the cases, we will have a reciprocating screw machine. So nowadays in industry we will not be able to see the second type. This is actually, it was earlier it was used in industry. Nowadays this is ram or plunger type injection molding machines are not commonly used. And the functioning of the screw system is explained here. I will have very short discussion on this. That is, the resin is melted. So the plastic resin is melted by mechanical shear. So what is meant by mechanical shear is the shear force that is exerted by the rotation of the screw. So we are all familiar with the shear force. When the screw rotates, there is a very small space in between the screw flight and the barrel. So there is a very small clearance. So through this clearance, the plastic needs to move forward. So that barrel is being heated thermally. That is why we have thermal energy is being given to the barrel. So along with the thermal energy and the shear force, the plastic will get plasticized. So the molten resin is conveyed and it is collected in this screw chamber. So that is how the process will go on. And then the material that is being accumulated in front of the screw is injected into the mold. So that is, here you can see the mold is being explained. and the plastic material is being conveyed. So this picture is only for intended to give a knowledge of how the plastic moves forward. So you can see that here the plastic granules are of larger size. When it moves through the screw flight, the size is getting reduced. It is finally get reduced, and now here it is being plasticized. So as the plastic material moves, this barrel is being heated by the band heaters that is placed externally, and the plastic material in granules moves forward and gets the particle size get reduced, and then plasticized and gets accumulated in front of the screw. So that is how the process will go on. This is simply the melting process, and the plastic is getting accumulated. So now we'll have the reciprocating screw machine, how it functions. Once the plastic material is been added, so the entire screw moving forward is used for injecting the plastic material. So once the plastic is being melted, it will inject the material. So in the previous picture, here you can see in the previous picture, you can see the plastic, the screw is in this position. The screw position is backward, or it moves backward, and when it rotates, it moves backward. That is how the process will go on. So once it is accumulated, the plasticized material is accumulated, then it will have a reciprocating motion. Further, it will not have any rotation. It will have a very fast reciprocating forward motion. That is how the material is being transferred. So normally, once the material is being transferred, the screw will stay in the forward position for some period of time. Simply we can say until the resin began to harden inside the mold. So once it moves forward, the plasticized material will be transferred to the mold, and the screw will remain there for some period of time, so as the plastic that is entered into the impression should remain there itself and get solidified. So for that particular time, the screw will remain in the forward position itself, and then the screw will again start to retract, and the once here it is shown that the screw is going to retract. So when the screw retract backwards, again the plasticization occurs and the material gets accumulated in front of this. So why I am saying this is because this is going to be a cyclic process. So once the material is being added, this process is going to continue for a number of cycles. So when we require, suppose we require 10,000 product and we are having single impression mold, once we add the machine and set the machine will continue its operation without any stoppage, but this process is cyclically being continued. So that means one material is added, the added material will get plasticized, get accumulated, it is injected, again the screw will rotate and move backward. So like that, the operation will have a cyclic effect, or cyclically the process will go on. So what is going to be advantage of this process is that the screw plasticization will give uniform melting. So one important thing regarding thermoplastic material in injection molding is that we require uniform melting of the plastic material. Otherwise, if the plastic is not uniformly melted, we'll have unmelted plastic material that is going into the impression, and the process will not be continuous then. And again, we'll have very good dispersion of additives. So mixing of the additives is very important. When we come to injection molding process, normally we will have 2-3 additives that is commonly used. One most commonly used is the color. In some cases, we will have certain fillers also. So suppose we are going to have color. This color is going to be used in a very small quantity. So the entire plastic material needs to get that particular color. So before that, we require to have good dispersion. And when we are using a reciprocating screw injection molding machine, we will have very good dispersion. And compared to other processes, we are having lesser injection pressure. That means when we are using the ram injection molding, we will have greater resistance for the plastic to flow, and the pressure requirement is very high, and we'll have fewer stresses. So it is the stress induced in the part that is going to affect the performance of the part. In injection molded product, one of the main problem that we are going to face is regarding the internal stress that comes into the product. So we require the product to be made with lesser internal stress. And compared to other processes of ram injection molding, screw injection molding will have lesser stress that is induced into the part. And the last one is very important, that is we have very fast total cycle. That means the time required for the cycle to complete is very less when we are having screw plasticization. When we come to the injection molding process, normally in industry, we can save 1 second of time. When it is being saved, we will have plenty of money saved at the end of the day, because 1 second in one cycle is very important when it is going to be 24 hours. So suppose the total injection molding cycle time that is in one process is uh, 50 seconds. If we are able to save 5 seconds, we are going to have huge, that means huge improvement in the profit that we are going to have at the end of the day. So this is going to be the RAM injection molding machine. This is, as I said, this is not commonly nowadays being used, but for academic purpose, if we study this, so here we are having a RAM that is used for plasticizing the material, and for spreading we will have a torpedo. So we have the same arrangement, but because we don't have any screw barrel assembly, we are only having a RAM, and the plastic material is allowed to be injected. So for that we are having this RAM arrangement, and we are having a torpedo for spreading the material, and we are having the mold mold is being fixed. The core cavity arrangement very similar to that of the other type of machine, but this type of machine is nowadays not industrially important. And coming to the materials used in injection molding, we'll have almost all the thermoplastic materials which can be injection molded. So this is one of the beauty of the system. If we are having one injection molding machine, we can have almost all the type of thermoplastic materials to be processed. So suppose we require different varieties of products from different types of materials, one single machine is enough for all the thermoplastic materials to be processed. And we are having resin to be having low melt viscosity. So that is another important requirement as far as the material is concerned. Melt viscosity in injection molding is to be less. Why? The reason is that if the material is having high melt viscosity, the process will not be very smooth enough. So here you can have the explanation. Melt viscosity must be less, so that the material flow through the runner, gate and cavity, and all these things to be done with a minimum injection pressure. So the injection pressure should be less. Why it should be less? To reduce the internal stress. So the material, if it is having high melt viscosity, will have more internal stress also. So that is a thing. So the resin normally used in injection molding will have different grades of low molecular weight compared to other processes. That means when we compare it with extrusion, normally the material that is used in injection molding, the grade of material used will have a different grade of injection molding. So normally we will classify this grade based on the melt flow index value. So as the melt flow index value is higher, we say the melt viscosity is less. So materials having high melt flow index is used normally for this process of injection molding. So with this particular slide, we will have a conclusion of this particular session. So this shows a pie diagram of what all things are happening during injection molding cycle. So here we can see this cycle is being continued in the injection phase. So once we can start with the mold closing. So once we are having initially the mold closing, means at the end of the mold closing, we will have mold safety conservation, and after that we will have the injection phase. So once the mold is being closed, we will have the injection process, and after that we will have a holding phase. That means to ensure packing of the material in a proper way, we need to keep the material or the screw in the upfront position for some more period of time, and that particular period is known as the holding time or the holding phase. And after the holding phase, we'll have the cooling phase. So we can see that the cooling phase means the material is being completely being cooled to temperature near to room temperature, say precisely we say 45 to 50 degrees Celsius, because further cooling it will take more time, and more time the cycle time is going to have adverse effects. So we require to take a temperature where the plastic is being solidified to a level that we can have the material removed without any distortion. And after that, we will open the mold, and we will open the mold means once it is being opened, mold is opened, it will take further period of time for the material to be ejected. So open period means there the plastic that is being formed inside, we can have proper ejection also to be done. So once during the open period, in some of the cases where the plastic holding is more, we require to have proper cleaning. In some cases, we require certain functioning done by the help of mold cleaning, or in some cases mold release agents, etc., to be used. And all these things are being applied during the open period. That is, the mold is in the open position. We will apply all these things, and the mold is allowed to be closed again. So this cycle continues during the entire operation of the process. So that is simply we can say the injection molding process proceeds. And here there is some more technical things are being used in the holding phase. We'll have the gate freeze off, and mold safety is associated with the mold processing. And the mold safety is associated with the mold to be properly be closed and opened. We need to have very specific care in mold opening and closing, and the whole operation is continuing like this in the injection molding process. So with that, we are coming to the conclusion of our this particular region, this particular module of injection molding. We will have detailed discussion about the molding process, as well as the parts associated with the injection molding processes. We'll have detailed discussion in the next class. Thank you.